The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone. My name is Chad Smith, and I'm one of the co-authors of Demand-Driven Performance Using Smart Metrics. For audio quality purposes, we've muted the audience. If you have questions, please go ahead and hit the question box on the webinar control panel. Today is the first webinar in a series of 3. The other 2 will be held actually tomorrow. Now, if you didn't sign up for those other 2 tomorrow, they are full, but we have scheduled an entirely new series for March, and you can find more information about that and sign up for that new series at demanddrivenperformance.com. With me on the webinar today is Deborah Smith, who is the lead author for the book Demand-Driven Performance Using Smart Metrics. Deborah is a leading authority on this topic. She's authored 2 additional books on this topic, TOC and its Implications for Management Accounting in 1995, as well as The Measurement Nightmare that was published in 1999. So I'm now going to turn it over to Deborah, and she's going to take you through the first part of the webinar. Deborah?
Good morning, and thank you, Chad. A deep truth lies at the heart of how we perceive reality and how we behave in light of that perception. It is simply what we know, yet challenging a deep truth is extremely difficult. Nobel Prize-winning physicist Niels Bohr once said, "The evidence to replace a deep truth must be so compelling, so obvious, that people let go of their attachment to the status quo." In other words, once you see a deeper truth, you simply can't go back. Today's deep truth is the assumption that return on investment is maximized through and directly corresponds to the minimization of unit cost. Everything from curricula approved by academia to the approaches and solutions offered by consulting firms to the major enterprise resource planning ERP software providers is a part of this deep truth. Entire corporate careers have been built around it and devoted to promulgating it. Challenging this deep truth can be career limiting. What if today's deep truth is totally, completely, unequivocally false? To prove this, we'll need to understand 2 key principles of supply chains. The first law of manufacturing is all benefits will be directly related to the speed of flow and information. And this is a quote from George Plazel, and you can find it in Orlicky's Material Requirements Planning 2. Flow of information in the form of demand signals is sent through the supply chain, and a flow of information and materials in the form of supply signals responds. A critically important caveat that we have added in our book is that both information and materials must be relevant to market expectation. We frequently observe organizations drowning in oceans of data with little relevant information and large stocks of irrelevant materials. Too much of the wrong stuff while simultaneously stocked out of the right stuff. All benefits is a fairly encompassing statement, so let's be sure we're very clear on what we mean and why we claim that. When a system flows well, service is consistent and reliable. Today, that's a necessary condition to ensure maximization of revenue and that revenue is protected. Market share grows, or at a minimum, it doesn't erode. When a system flows well, inventories are minimized. Raw and pack, work in process, and finished goods inventories will be minimized and directly proportional to the time it takes to flow between stages and through the total system. Additionally, unnecessary ancillary expenses are eliminated or at least minimized. When flow is poor, additional activities and expenses are incurred to close the gaps in flow. Examples would be expedited freight, overtime, rework, cross-shipping, and unplanned partial ships. Cash flow follows the rate of product flow. Materials and labor are converted to cash at the rate of flow to market demand. When flow is maximized, material that a company paid for is converted to cash at a relatively quick and consistent rate. This makes cash flow much easier to manage and predict. Every for-profit company has a universal primary goal: maximize some form of return on shareholder equity or return on investment, ROI. The best sustainable way to achieve that goal is to promote and protect flow. This is the very definition of an efficient manufacturing and distribution system. Conversely, one of the fastest ways to compromise ROI and system efficiency is to make decisions and reinforce behaviors that impede or block flow. Let's get some historical perspective. Prior to 1920, there were few to no external shareholders and little unsecured debt. There was little need for elaborate financial reports. In contrast, management accounting was relatively sophisticated and had evolved to provide essential information needed to manage the ever-growing large-scale production of textile, steel, and the growing market of mass-produced consumer goods, automobiles being a very good case in point. After the turn of the century, detached supplies of capital required firms' managers to supply external financial reports. This, coupled with the stock market crash of 1929, resulted in the creation of the Securities and Exchange Commission to regulate publicly traded companies and establish external financial reporting requirements. And Generally Accepted Accounting Principles, commonly known as GAAP, was born. The inventory costing procedures adopted by public accountants had a profound effect on accounting reporting. But for decades, those two practices coexisted. As reporting complexity requirements increased, management accountants increasingly focused their time and effort on ensuring that financial accounting requirements were met and financial reporting were released on time. You couple this with the increasing distance of the finance function from operations, and you see you have a growing disconnect between what's good for managing flow in operations and how finance collects and reports information. In 1965, Material Requirements Planning, MRP, revolutionized the way companies calculated what to make and buy and when. In 1972, closed-loop MRP integrated capacity scheduling and reconciliation. But the nail in the coffin for relevant information and management accounting to help operations drive flow came in 1980 when MRP2 was born. MRP2 integrated financial reporting and provided an automatic roll-up of the different layers of product structure to one single cost number. The system designed to capture standard routing time and material usage input became focused primarily on providing a costing system for GAAP. By 1990, MRP2 had evolved into the widely adopted Enterprise Resource Planning, otherwise known as ERP, systems of today. Today, at the core of every fast, powerful, expensive ERP is MRP2 and all of the problematic unit cost rules assumptions that are GAAP-based. In the past 25 years, the practice of management accounting has stagnated nearly into oblivion, and access to relevant information to drive flow has been largely lost. This has been going on so long, most managers, executives, and even accountants have come to accept GAAP costing as relevant information to direct tactics and make decisions and drive actions. The problem of the disconnect in how to define and access relevant information has been pointed out repeatedly in accounting literature and many other forums for the last 25 years. Johnson and Kaplan wrote about that problem in 1987 in Relevance Lost. I personally authored 2 books on the subject in the 90s. The identification of the problem and its scope is undeniable. It is the solution that has been and still is in question. GAAP concentric information has become conventional practice. Today, companies act as if unit cost minimization is undeniably the first law of manufacturing. Companies are led to believe that cost improvements everywhere fall to the bottom line. This belief and the pervasive behavior it drives have been hard-coded into all our information reporting and performance measures. All of these reporting measures, tactical planning, and execution actions seek the following 4 objectives. Minimize total product unit cost. Maximize resource efficiency everywhere. Strive for positive overhead variances of labor and volume. Initiate cost reduction efforts with emphasis on machine, labor, and inventory reductions, quantified on a fully absorbed standard cost, a cost according to GAAP. We simply can't see another way. This isn't new news to accountants, but most non-accounting managers are unaware of the differences but very aware of the negative effects caused by unit cost and local efficiency gap rules, conflicting with the rules necessary to speed flow to and through the system. We're going to use an example from our new book, Demand-Driven Performance, using smart metrics to clearly demonstrate the problem with two competing strategic focuses. Our example plant has both a make-to-stock and a make-to-order product environment that it supplies to the market. The starting point is a common operations key performance indicator. We're going to be referring to that as a KPI. The plant receives a credit value of product unit cost for every product produced and is measured against the sales and operating plan performance. That's at forecast. So if the plant feels pressure to maximize monthly profit plan, COGS, dollar credit, that's their KPI, I could put in here minimize unit cost or maximize resource efficiency, and I will get the same effects. And people behave according to their metrics. Then plants are going to try to maximize making high COGS dollar products. Some items have more COGS dollars than others, and plants are trying to maximize high COGS dollar products. Then departments tend to produce the high COGS dollar items at the expense of the low items. When this happens, some make-to-stock products incur stockouts. If I set up more to increase product unit costs, if setting up more increases product unit costs and lowers resource efficiency, and plants try to maximize high COGS dollar products, then plants are going to pull ahead orders to increase the batch size for make-to-stock orders. If plants are pulling ahead to maximize those high COGS dollar products, then some make-to-stock products are overstocked. And what I have right now is some of my products are in stock out and some of my products are stocked out. Additionally, when departments tend to produce the high COGS dollar items, that drives the make-to-stock products to be overstocked. Plants receive COGS dollar credits when they ship to distribution centers, not when they ship to the customer. Then plants tend to produce to stock even when there is no demand signal. They extend the forecast and make the batches even larger. When that happens, again, I have some products overstocked and even more products in stock out. Make-to-order and make-to-stock share common capacity and materials. And when plants pull ahead and increase batch sizes, my make-to-order backlogs grow and we ship late. And unfortunately, it's all coming from a KPI driven from gap unit cost measures that have nothing to do with flow. What we have is a problem, but it gets worse. So let's just take a look at how we can continue with this. These undesirable effects drop to the bottom, and let's see what happens now. There's common labor and machine resources, and some make-to-stock products are overstocked. Capacity is consumed unnecessarily. When that happens, we create artificial bottlenecks. And when we create artificial bottlenecks, we feel pressure to add capital. Some make-to-stock products incur stockouts, and plants feel pressure to meet their other important KPI, which is on-time performance to their market. When that happens, plants feel pressure to expedite that late work. Make-to-order backlogs grow and we ship late, and plants feel pressure to meet their KPI. Plants feel more pressure to expedite late work, both from the distribution centers that are stocked out and from the customers that are not getting their shipments on time. When capacity is consumed unnecessarily and plants feel pressure to expedite late work, capacity is not always available. And that adds to the pressure we feel to add more capital. We also feel pressure to add overtime. If there are common raw materials and subcomponents, and some make-to-stock products are overstocked, then materials are consumed unnecessarily. When plants feel pressure to expedite late work, and materials are consumed unnecessarily, materials aren't always available when we need them. And that leads to the pressure that we feel to add more inventory. When materials aren't available, we feel pressure to expedite the materials in. When plants feel pressure to expedite late work, we emphasize speed. And when people emphasize speed, we often have quality issues. When we're working overtime, we often have quality issues. And the end result is that the 5 key performance indicators, the 5 core mathematical components of return on investment, all go the wrong way at the same time. What we have here is 2 competing KPIs. Plants feel pressure to meet their on-time performance and satisfy the market, and that's competing with the pressure to maximize their unit cost measure. Obviously, we can't have 2 first competing laws. We can't have 2 first laws at all. So let's look at the common management objectives that happen. When plants feel pressure to maximize monthly profit COGS, that cost-centric measure, versus plants feel pressure to meet their on-time performance at KPI, there's no way for them to win. In fact, they're trapped between 2 masters that they can't please. Do you see the problem? Let's look at a few more examples and make it very clear. They're different and conflicting actions that are required by these 2 competing strategies. Let's look at efficiency first. Cost-centric action would ask me to run larger batches, extend the forecast, wait and run only on optimal resources to get the least unit cost. A flow-centric approach would tell me to protect scarce capacity resources, run smaller batches to pull, and run on any process-capable resource. Margin maximization. A cost-centric focus would focus on lowering unit product cost. Flow-centric, we would focus on increasing service levels, premium pricing, and leverage our constraint resources. Inventory turns. A cost-centric focus would impose a total inventory dollar value at the end of time periods. Postpone inventory receipt. Mandate across-the-board inventory reductions. A flow-centric says we're going to commit to a strategic stock positions that meet the lead time strategy necessary to satisfy our market expectation and our sales operating plan and strategy. Unfortunately, there are more of these, so hold on. Let's look at budget performance. A cost-centric focus is achieving standard unit cost. A flow focus is based on the incremental cost of leveraging flow to the market. Volume maximization, lower price and raise order minimums. Or focus on service, lead times, and lowering order minimums. Continuous improvement. We want to identify unit cost reduction opportunities through increasing resource efficiencies, raising batch or minimum order quantities, and/or labor reduction. Flow-centric, we're focused on identifying the largest sources of variation and target removing them so we can lower our lead times and safely reduce our investment in all strategic buffers. What we have is a mess and a constant series of trade-offs based on a conflict that never should have existed to begin with. Most controllers and operations managers feel they are trapped between 2 masters and they can't win. The key to ending the conflict is knowing what is relevant. The following is a quote directly out of the most preeminent and best-selling managerial accounting book in the world by Garrison, Noreen, and Brewer. As a side note, Dr. Noreen and I co-authored The Theory of Constraints and Its Implications for Management Accounting in 1995. That book was the outcome of a grant from the IMA Foundation, that's the Institute of Management Accountants, for applied research for that year, and was the first independent study on the theory of constraints. The point this book makes, if you actually ever read it, is there are 3 critically important points. The first is the definition of relevant information as the costs and benefits that will differ between the alternatives. These are the only relevant costs and revenues to be considered. The second thing is distinguishing between relevant and irrelevant information is critical to streamlining time and effort. But most importantly, including irrelevant information results in bad decisions. Many of the bad decisions that we just looked at in our effect-cause-effect diagram, taking us from the KPI using cost measures to the undesirable effects in our supply chain. Remember, the definition and test to determine relevant information is the cost and/or revenue that will change between different alternatives, and is the time frame that determines the relevant range of activity within which those assumptions about what's variable and what's a fixed cost remain valid. In the long run, all costs are variable. In the short run, all period costs, including direct labor, are fixed, and that means they are irrelevant. Unitizing fixed costs creates the false impression that overhead costs, including direct labor, will vary up or down with changes in activity volume levels. Controllers and most accountants know this, and when asked to provide costing information, will often seek to qualify what and why the information will be used for everyday hourly tactics to drive unit costs down or acted upon across the organization. The further away from operations finance becomes, the less intuitive they become regarding cost behavior and the negative impacts to flow of local cost actions. To determine the relevant range for tactics and metrics, we need to start at the annual sales and operations plan. Clearly, managers can vary some of their fixed costs inside their annual plan, and a very few inside their quarter. But both annual and quarterly financial measurement periods are based on forecast plan. Tactically, operations can still move the relevant range and some activity of labor. I can still maybe add a shift, take a shift off. What overhead costs can be varied inside a month, a week, or a day? If you ask any plant or operations manager, and they will usually agree that their costs are fixed inside of a month, and at the point where schedules are released from planning to execution, the only relevant information in execution is the flow of the right materials and information to meet real demand pull. Any cost-based tactic or action that breaks down or impedes the priority of the right flow increases the total cycle time, increases working capital, and lowers the revenue opportunity for the time period. The time period fixed costs remain unchanged, but the discretionary spending, expediting, expenses for overtime, and premium freight, they all go up. Forecast-driven schedules, cost-based rules, tactics, and metrics need to be replaced with relevant time-based metrics that create real-time visibility to the status of demand-driven flow. Today's ERP reporting is largely blind to knowing what is relevant to drive flow. In order to know the rules for what is relevant, we have to understand the second principle. Chad, can you take over from here?
Absolutely. All right, so let's get into the second principle here that we need to convey to you, and that's the simple fact that supply chains are more complex. I don't think that it's a revelation. I don't think that most people would fight us too much on this. And one of the things that we did in research for demand-driven performance is try to give you a feel for just how much the world has changed between 1965 and 2013. Now, why did we pick 1965? Well, something significant happened in 1965. In 1965, we actually got the term MRP. In other words, in the mid-60s, what we saw was a real codification of what modern or conventional planning systems do and the rules that they use. Additionally, we saw kind of the birth of cost accounting, or at least the prevalence of cost accounting beginning with computerized systems, the prevalence of computerized systems. And of course, as Deborah said earlier before, the kind of the nail in the coffin for relevant information was the incorporation of the costing data into the MRP systems, and that's where we had the revolution of MRPII. Now, we won't take you through this entire chart here. Now, it is available in the book, but one of the things that might be just kind of fun here is to take a product variety as an example. And one of the things that I looked at was an example with toothpaste. And if you look back in 1965, Colgate and Crest, okay, each only made one type of toothpaste. Now, today, actually in 2013 or 2012, I should say. That's when I was able to get the data. Colgate claimed 17 types of toothpaste, and Crest claimed a whopping 42 types of toothpaste. In fact, toothpaste is actually a pretty good example because right now in retailing consumer products world, there is a pretty big battle being waged over toothpaste, believe it or not, because the retailers have kind of had it with the brand companies because they simply can't manage the shelf space very well because there's so many alternatives. So let's go ahead and move on there, Deborah. What we really have here today is supply chains that are an order of magnitude at least more complex. Our supply chains don't look like chains anymore, they look like webs. And at each intersection or node on our supply quote-unquote web, there is typically a manufacturing entity or a distribution entity running some form of ERP system with those MRPII assumptions, the problematic assumptions, both planning to forecast as well as the cost-centric rules. And what's happening is that variability is being passed and amplified due to the forecast error that is increasing, as well as the cost-centric rules that are inappropriate for the circumstances that we see today. So the wrong rules inside of each node transfer the variability, and the greater amount of connections kind of amplifies the variability, creating a situation that we commonly refer to as bullwhip. Let's go ahead and advance. Okay, this brings us to something called the Law of System Variability. Now, if you read the Apex dictionary, and unfortunately I've actually done that from cover to cover a couple of times, what you'll see in there is that there's an interesting definition called the Law of Variability. The problem with the Law of Variability is that it's focused at the discrete process level. It really doesn't speak to the system. So in the book, what we did is we came up with a new definition called the Law of System Variability. And what the Law of System Variability says is that the more that variability is passed between discrete areas, steps, or processes in a system, the less productive that system is going to be. And the bigger the system, okay, the more areas, steps, or processes and connections in the system, the more erosive the effect to the system or productivity, the system productivity will be. And you can illustrate the Law of System Variability pretty easily. So what we've done is we've created a graphic. Down below you'll see a network of dependencies. Now this network could represent a product routing, it could represent a product structure, or commonly referred to as bill of material. It can even represent a project network. And essentially, as we put more and more dependencies into play, certainly dependencies that are parallel and or feedback, we get an erosion to output and an expansion to lead time. And that can be illustrated by that big black variability wave. You can also maybe call it a supply continuity wave. And what we're really saying here is that delays accumulate, gains don't. All right? So that as we move through the system, a bigger, more complex system, we get an increasingly amplified sense of shortage or supply continuity. Let's go ahead and go forward. So here you see the variation accumulation and variation amplification. Okay, let's go forward. And really what's happened is the game has essentially changed. Okay, the assumptions that we had earlier in the century about the way that supply chains behaved, the way that systems behaved, are beginning to break down because of the emergence of something called a complex adaptive systems, or CAS, okay? And so what I'm going to do here is I'm going to turn it over to Deborah, because Deborah does an excellent job of explaining what CAS does and how CAS changes the game on the industrial world.
Thanks, Chad. He had to read the Apex dictionary. I had to read all the complex adaptive system books that are out there that just came out in the last 5 years. So both of us have had an interesting reading list that puts you to sleep at night. Protecting and maintaining flow in these new supply chains requires that we understand the rules. If the game is changed and we don't know the rules, then we're going to be at a very big disadvantage to compete. So we need to understand complex adaptive system rules and why they relate to speeding flow in a complex adaptive system. New thinking to build the right rules and tools to make the status of flow visible in real time. You can't measure what you can't see. And the last thing that we need to understand is, what are smart metrics to help an environment manage in this new volatile world? Smart metrics are the outcome of the right rules and tools and a major evolution in the management accounting body of knowledge. Complex adaptive systems are about getting the right rules right. So let's start here. It's a new science and it explains complexity. And when I say new science, complexity came out in the late 80s. I'm going to say the late 80s. Dr. Goldratt understood the idea of complex systems. Complexity has changed. The way science looks at complexity has changed dramatically in about 2004 forward. Only since about 2008 has logistics, economics, and I'm going to say very theoretical research started looking at complex adaptive systems to explain business and supply chains. CAS have well-defined rules and predictable behaviors that govern system flow, revenue, and cost. Conventional thinking, costing, and reporting information is based on a linear system rule set and mathematics. And don't go away on me here. That simply means I do this, then I do that, then I do that, and it's a nice linear flow. The rules of how costs behave and how flow should be protected are very different in a linear system. And in fact, most of them, many of them, and most of them are opposite. Most business leaders, operational personnel, and academics don't know or understand these differences, their implications, and the opportunities. So how different are they? They're very different. So CAS deserves a whole webinar, but not today. And what we're going to do is just take a few minutes to highlight the critical differences between the rules governing linear systems versus nonlinear complex adaptive systems. The first trait we're going to look at is the method to understand the system. The method to understand a linear system is by studying each individual part. The whole is the sum of the parts. This is just basic Newton physics. To understand a nonlinear system and predict CAS is impossible by studying individual parts of the system. This means local resource efficiency has no connection to the efficiency of the system. To understand CAS dependencies and interconnections, you must understand the system as a whole. This trait is why becoming demand-driven starts with mapping the connections and interconnections of flow through the system from quote to cash. Second is system predictability. A linear system is predictable and it's stable, whereas a nonlinear system is dynamic and predictions have a very short life. Forecasts are destined to be wrong inside a short-term execution horizon. I cannot tell you the millions and hundreds of millions we watch being spent on a better forecast tool. It's not going to help. It's like getting a better crystal ball because the system I'm attempting to predict doesn't have a long life. This trait is the driver and the logic behind creating strategic decoupling points to create shorter independent planning and execution horizons tied directly to pull, not forecast. This is the whole point of demand-driven MRP. And Chad can bring you up to speed on how to find more out about that at the end of the webinar. Third, system output behavior. A linear system outputs are equal to the inputs, and the outcome is additive. I put in 1, I add 1 more, I add 1 more, and I get 3. A nonlinear system are governed by a few critical points, and this creates the ability to manage a complex system from a very few, relatively few critical points. This is known as the lever phenomena. I'm certain everybody's heard of the butterfly phenomena. The flap in South America causes a typhoon in the South Sea. This is basically the same thing. A small change at a critical point leverages the whole system. A small change results in a large change in system output. These points are called control points in demand-driven. They're critical to identify, schedule, protect, and manage. They're also one of the central focuses of smart metrics. They're called drums in TOC, and they're called pace setters in Lean. Oh, slide boo-boo, but we'll fix that. Fourth, a linear system follows normal distribution statistical curves as a Gaussian model. Now, don't check out on me here. That's the normal curve you always see. It's got a big bump in the middle, and the tails at the end are very small. The tails of the distribution in a Gaussian model can be totally ignored. They're considered irrelevant events, they're outlier events, and they don't direct any action. A nonlinear system follows Paretian rules. Paretian statistical models are where the tails describe those few critical points, and they define the relevant information to manage the system output. They contain the lever point phenomena. In fact, what they do is they point and focus. Everybody's heard of the 80-20 rule. In nonlinear systems, it's more like a 99.9 to 0.1 rule. Fifth, a linear system can be optimized. A nonlinear system cannot be optimized, but it can do something even better. It can learn and continuously improve. Complex systems are inherently simple to manage if you identify, understand, and manage or protect the few system leverage points, and if you strategically decouple a long time horizon into short planning horizons that you can predict and make stable. Our point is the fundamental science and math that's the foundation of all of the applied sciences, economics, accounting, operations management, and logistics has dramatically changed, and that gap is widening between those who get it and those who don't. The gap between the knowledge and the application defines that opportunity. This slide represents some early adopters who have shared their results, 4 of which are presented in our book. The others have presentations that can be viewed at Demand Driven Institute and Constraint Management Group websites. The most interesting thing to note is they span completely different industries, from electronics and aerospace composites to heavy equipment, from food and fast-moving consumer products and packaging to steel mills and foundries, from automotive to waterworks and engineer-to-order piping systems. Yet all of them followed the exact same strategic process of embracing flow as the prime directive and taking steps to become demand-driven. In the past, quantifying the gap between the flow and cost-centric strategies have all focused on Plausel's first law. A change in flow equates to a change in cash velocity, and that creates a change in return on investment. This equation, however, must begin not at flow, but at relevant information. If we don't fundamentally grasp how to generate and use relevant information, then we can't operate to flow. Moreover, if we're actively blocked from generating or using relevant information, then even if we understand there's a problem and we know what would be relevant, we are powerless to get the information and do anything about it. We've clearly demonstrated that the core problem plaguing most supply chains today is their inability to generate and use relevant information to drive flow that drives ROI. So let's go through this equation and definitions and make certain that everybody understands exactly what we're talking about. We're defining a change in visibility as the change in the visibility to relevant information for making decisions. Variability is defined as the summation of the differences between what we plan to have happen and what happens. And here we're talking about the plan of time from start to finish and the plan of quantity from start to finish. Notice I am not saying cost. Flow is the rate at which a system converts material to the product required by a customer. Cash velocity is the rate of net cash generation, those sales dollars minus your truly variable costs, also known as throughput dollars in theory of constraints and contribution margin in management accounting. If you take the sales minus the truly variable costs and then subtract your period operating expenses, that's cash velocity. Net profit divided by investment is, of course, simply the equation for return on investment. So let's take a deeper dive and make sure we understand the assumptions behind our claim that a change in visibility causes a change in variation. This is a two-way street. If visibility to relevant information goes down, variation will increase, and the costs of overcoming that variation will rise, and/or the velocity of flow decreases. System reliability and stability decrease, and flow time increases. The major assumptions are, you can't measure or manage what you can't see. So therefore, visibility to relevant information across the supply chain ensures system coherence. Coherence is the key to keeping a system flow synchronized. Coherence is the principal driver of success in a CAS system. Aligns priorities and schedules, defines when or where to act, and people will self-organize to solve a problem when they agree on and can see it is the cornerstone to empowered workforce. If people see a problem, agree on it, get out of their way, they're going to go fix it. So obviously the next question is, how do you move an organization from cost-centric to flow-centric and demand-driven? Chad, can you take over?
Yeah, thanks a lot, Deborah. I think also on the previous slide, what's interesting too is that you can also make the statement that if you have irrelevant information, chances are that you'll also actually create more variability, right? That if you're focusing on the wrong things, you actually create more variation in your organization. All right, let's get a little bit, or let's go into the blueprint for change, something we call the smarter way. And we don't want you to misunderstand what we mean by getting smarter. We're not saying that people inside organizations aren't smart. Organizations are full of very smart, experienced people. What we're really saying is that collectively, the people together are failing because the organizations together aren't producing the right kinds of information, aren't giving the system enough of that right visibility. Now, the first component of something we call the smarter way is to install what we call the right thoughtware in the organization. And one of the things that we always tell people is before they make large investments in hardware and software, it's absolutely crucial that they make the investment in thoughtware. And what that really means is the people's ability to think and communicate systemically. And if people in the organization can't think and communicate systemically, then in a lot of ways, if you really think about it, how can they take actions to drive system return on investment? The next thing is once they become aware of how to think and communicate systemically, then what we need to do is we need to become demand-driven. We need to design an operating model that is appropriate to protect and increase flow to the market. And finally, once that model is put into place, we have to deploy the right kinds of metrics to not only sustain that model, but improve that model over time. Deborah, you want to advance for me? One of the things that was pretty interesting here is just this week, we did a webinar with the Institute of Management Accountants, and on the line we had over 1,000 financial professionals. Okay, these are people that are accountants inside of organizations. We had over 1,000 people across 41 countries, representing anything from Global 500, Global 100 companies, all the way down to smaller job shops. And what we did is during that webinar, we asked them a few questions. And take a look at the first question. And this is a question that we asked them right out of the gate to kind of set the stage. It says, what do you think is the biggest factor in return on investment? And we had 12% say lowest unit cost. We had 53% say best resource efficiency, and we had under 35% say best total system flow. Now, of course, we're going to orient towards the answer being C, but what you can see is the vast majority of people are oriented right to that cost-centric philosophy. The next question we ask them is, what wins out in your organization? Cost-centric tactics and actions, flow-centric tactics and actions, or do you oscillate back and forth between expediting and protecting flow and actions to protect costs? Now, combine answer A with answer C, and you see we've got a very big problem. In other words, the vast majority, over 80% of the companies out there, or the people that were polled in this, which represents hundreds of organizations, are saying they're either focused on the wrong thing or they're caught or trapped between the two things, between cost-centric and flow-centric strategies. The next question we asked was, how would you describe the complexity of your company's supply chain in the last decade? Has it stayed the same? Has it increased? Or has it decreased? Of course, the vast majority of people say it's actually increased, nearly 80%. Finally, this is a really interesting one. How would you rate your ERP system ability to focus on the relevant information? Now remember, the power and the promise of ERP was that we could manage large amounts of data and make that data available to the organization on demand across the organization. The idea, the assumption was if people had access to data, they could then harvest that data and convert it to information. Now, is that really happening today? If you look at what, and remember, this is coming straight from the finance portion of the organization, guys, okay, over 1,000 people. They're saying nearly, about 78% of people are saying moderate to poor. Excuse me, over 80% are saying moderate to poor, that their ERP system does a poor job of giving them relevant information, or a moderate job of relevant information. Now, I think all of you can appreciate just how much money organizations and industry spends on ERP, and to say it's moderate or poor, it certainly means that we've got a long way to go on providing people the right kinds of information.
Chad?
Yeah.
Could I take a shot at this for just 1 second? I think there's an important point I'd like to make. I think another thing that's really important is to point out when we ask these questions, because the presentation that you're seeing is exactly the presentation that we presented to them. We asked that first question as the second slide, right after we were introduced. People gave us a very honest answer. I also want to point out that there is no difference between best resource efficiency and lowest unit cost, because a best resource efficiency is based on what's driving you to a lowest unit cost, because that efficiency is all based on dollars, not time or flow. The second thing I want to point out is that we asked the second question after we showed that diagram that said, here are 2 competing strategic objectives, and these are the things that happen. It pulls a company back and forth and causes all these problems. People saw that, and 43% of those people said, that's us, that's what we do. The other 40% says, we don't even get that far, we just go down the other road. The last one is, after Chad explained complexity, people related to that, and we didn't ask anything about the ERP system until we got to the very end. We got past the explanation of visibility. Do you understand what visibility means in information? So I think the placement of those questions is pretty critical. It brings you to a point of what people understood and then what understanding they gained.
Yeah, I just want to do one more thing, and that is I do want to bring up, if you're really interested in this kind of stuff, there's a great opportunity coming up this next month in Portland, Oregon at the Demand Driven World Conference. There's going to be company presentations from a wide array of industries, headlined by the Unilever company. Unilever is going to kind of open up the doors and talk about their experiences with the demand-driven concepts. And also, if you're really interested in seeing more behind what's in the book Demand-Driven Performance, there's a pre-conference activity, a day-long workshop with Deborah called the Demand-Driven Performance Workshop. There's group rates available for people in the Boeing organization, Unilever, and Apex. I know we have some Boeing folks on the line today. So with that, I think we'll go ahead and look to see if we've got some questions. Right now, I don't see any questions. Do we have any questions? Feel free to type those questions in if you do have some questions.